In this video, we are just going to practice writing some more molecular, total, and net ionic equations. But before you proceed, there are some really important concepts that you need to have working knowledge of before you go on. If you are still confused by any of these topics, please go over it once again and familiarize yourself with materials before you write the equations. Number one, naming. I can't even express the importance of that. Number two, writing the 5 types of reactions. And number 3, knowing how to distinguish the 4 states of matter. So let's do this example. Write the reaction between lithium and iron 2 nitrate. You can stop this video and write the molecular equation. Don't forget to balance the equation and include the states. I hope you wrote this single displacement reaction, where 2 moles of lithium solid reacts with 1 mole of iron 2 nitrate in the aqueous phase to form 1 mole of iron solid and 2 moles of lithium nitrate in the aqueous state. Now write the total ionic equation. You can pause this video to write the total ionic equation. You should come up with 2 moles of lithium solid reacting with 1 mole of iron 2 ions in the aqueous state and 2 moles of nitrate ions in the aqueous state. Then you form 1 mole of iron solid, 2 moles of lithium ions in the aqueous state, and 2 moles of nitrate ions in the aqueous state. From this total ionic equation, now write the net ionic equation. You can pause this video to write the equation. I hope you came up with 2 moles of lithium solid reacting with 1 mole of iron 2 ions in the aqueous state to form 1 mole of iron solid and 2 moles of lithium ions in the aqueous state. Let's do one more example. I want you to write the molecular equation for the reaction between potassium and fluorine. You can pause this video while you write the reaction. You should have written the synthesis reaction of 2 moles of potassium solid with 1 mole of fluorine gas to form 2 moles of potassium fluoride in the solid state. Now, can you write the total ionic equation for this reaction? I hope you noticed that the total ionic equation is exactly the same as a molecular equation because the states for all 3 species are solids or gases, so you don't break those down. And guess what? The net ionic equation is also the same. As a matter of fact, for most of the time, synthesis reactions, decomposition reactions, and combustion reactions, the molecular, total, and net ionic equations are all the same. If you are given this on the exam, you can just write the same for the total ionic and net ionic equations. Let's go back to the reaction of potassium and fluorine to form potassium fluoride. According to our state of matter rules, potassium fluoride should be an aqueous, not a solid. Let's go back to the definition of aqueous. Aqueous means to dissolve in water and form ions. So you need water somewhere to start with. In this equation, you have a solid and a gas, but no water or aqueous to dissolve the product potassium fluoride. So therefore, you have solid potassium fluoride. Another way to think about it is taking the salt in your cupboard. When you take it out of the container, it's a solid. But when you put it in water, the salt then dissolves and becomes aqueous. I hope this helps you with more ideas to write the 3 equations from the 5 types of chemical reactions that we discussed.